Welcome to our pre-AP notes over Chapter 7 and 8 still. We're going to be in what I term Part 2, and we're going to look at how we represent on paper ionic and covalent compounds, that is actually making drawings. So I show you this worksheet because it is your notes, and everything I'm going to be doing is explained and typed up here with step-by-step illustrations. But it is usually more helpful just to see examples done. So we're going to go right to some examples, and again, everything I'm about to say is in those notes. For ionic compounds, we're going to show dot diagrams. And so let's start at the beginning. How do we know it's ionic? Because we're going to have a metal with a nonmetal. We need that large electronegativity difference to get a transfer of electrons, and then the positives and negatives stick together. It's that electrostatic attraction I spoke of earlier in the first part of the notes. When we draw this on paper, we're going to do ionic compounds as dot diagrams. So you start by listing your metal. In this case, I'm going to pick sodium, and it has one valence electron, so one dot. And I'm going to stick with it chlorine. And chlorine has 7 valence electrons, so I'm going to stick with it 7 dots. Now when you do this, you really want to use pencil because I guarantee you're going to be erasing. Because what I want you to do after you show both of them is I want you to erase the electron on the metal and move it over to the nonmetal. Remember, the metals are losers. They always lose their electrons, and they will lose all their electrons or all their dots. In losing the electron, sodium has now become positive. Chlorine has gained the electron from sodium. I moved it over. We're going to draw brackets around the entire group to show all of these electrons are owned by the chlorine. And then I'm going to put the charge outside the brackets to show that it has a negative charge. And now this would be the actual bonding time. The sodium positive and the chlorine negative are going to stick together like little magnets. So it really is that easy. Except we could have a situation like magnesium iodide. Well, our metal is magnesium, and it comes with 2 dots. And you'll see why I'm spacing them out in a moment. Iodine starts with 7, being in the same family as chlorine. Okay, so magnesium, being the loser, is going to lose its electron to iodine. We're going to bracket all of those now belong to iodine. There's the negative charge, but magnesium is not a complete loser yet, and it needs to. It needs to get rid of that other electron. How do we make that happen? Well, we're going to need another iodine. So it's going to lose that electron to the second iodine. Brackets charge, and now that magnesium has lost 2, we're going to have that positive 2 charge on magnesium. Notice that's why in nature we will find the ratio is always 1 magnesium to 2 iodine, because nature knows it takes 2 iodines to take up those electrons from the magnesium. Also notice that the charges should always neutralize. If you wrote your compound correctly, you'd have the same amount of positive charges, negative charge. It will zero out. So it's a good way to check your work. So it gets no more difficult than this. You just have to have enough positives losing and enough negatives to gain to where all the nonmetals get 8 dots. They get an octet, and they have the brackets with the negative charge. And all the metals lose all their dots. Metals will always lose all their dots, lose all their electrons to become like the previous noble gas. It also gives them an octet, we just don't see it. Okay, so if I wrote out the electron configuration for magnesium, it starts as that. It had those 2 electrons. When it loses those, 3s is gone, and notice it has 8 electrons in the 2p. So that's the octet. So we are achieving an octet for all the elements. We're just not showing it around the metals. We're simply showing the metals have lost all their electrons, their valence electrons, and then the assumption is you know enough chemistry to know it's back to an octet. So good luck on your worksheets with ionic compounds. That is all there is to drawing dot diagrams for ionic compounds.